Ranty says he's going to take an auto level up a hill and target Snaefell on the Isle of Man. Now we also asked some flat earthers for predictions of where the crosshairs would be. So I contacted Ranty and asked him if I could make a prediction for the globe model. So what I have circled in yellow up here is what Ranty sent as his location, and surprisingly, it did work on Google Earth. It sent me to this location here at 1,475 feet on Winter Hill. Now I'm not certain if Ranty is going to be at this exact location when he makes this observation, so I decided to do a second prediction down here at a parking area, which is at 1,000 feet. So here are my predictions for what Ranty will see from both locations, and this is assuming that his auto level has a field of view of 1.5 degrees. Now the angular measurements are down from the horizontal line to the top of Snaefell, the turbines, and the tower. The calculations are based on standard refraction curvature rates, and the distance between Snaefell and Blackpool Tower is probably not correct. I just wanted them close together so you could see both of them. Now notice that everything is below the lower Stadia mark for both of these elevations, but on the left here at 1,000 feet, the tower and the turbines are higher than Snaefell, but over here on the right at 1,475 feet, Snaefell is higher than both the turbines and the tower. So how did I do these calculations? Well, first I started with the flat earth model, and here's some graphics I made when I went on Bev's Try Thinking channel, which is why I included water levels. Now on a flat earth, a horizontal line and a level line would be one and the same. So if you look through this auto level at this row of water levels, what you would see is that they would all be in alignment with that horizontal plane. I started with the 1,475 foot elevation, and here are the distances to Snaefell, the wind turbines, and Blackpool Tower. Here is the flat earth model, and I have included water levels to help the flat earth community understand exactly how this works. So here's a 1,475 foot horizontal line, which is the same as a level line. Therefore, if I had a series of interconnected water levels at this elevation, the water level would be above Blackpool Tower, it would be above the turbine, and it would be at the 1,475 foot level of Snaefell. Now, if I had a water level at the top of Snaefell and was able to string it all the way back so it was above Winter Hill, it would be 562 feet higher. So if the Earth was flat, what Ranty should see through his auto level is the top of Snaefell above that horizontal line and both the wind turbines and Blackpool Tower below that horizontal line. Now this is a photograph from exploring the plane. He was at an elevation of 940 feet, and as I told Bev, it is quite obvious that this is not a straight horizontal line. Now at Snaefell, 940 feet is actually below the horizon, but in any case, it is quite obvious that this matches the globe definition of a level line that curves downward with distance. And of course, when Bev and his companion saw this, they were coming up with all sorts of excuses. And what would a flat earth debate be without perspective being used as an excuse, which shows that they don't even know how their perspective drawing works. So here's the 940 foot horizontal line, or eye level. Of course, everything above that line converges down to the vanishing point. Everything below converges up to the vanishing point, which means that Snaefell would be seen above that horizontal line, and Blackpool Tower and the turbines would be seen below that horizontal line. Next, I move to the globe model, where a level line does curve down from the horizontal line. So now let's look at this elevation on a globe model, and notice too that the standard refracted horizon is 50.8 miles away. So I started with the flat earth model for that elevation. And then I added standard refraction curvature drop for each of these distances using the Metabump curvature calculator. So at Blackpool Tower, the top of the tower would be 1,299 feet below the horizontal line, which is 0.25 miles. And then I did an angular size calculation, which shows me that the top of that tower is 0.56 degrees below the horizontal line. So the turbines are 0.39 miles below the horizontal line, which is 0.52 degrees. Snaefell is 0.78 miles below the horizontal line, which is 0.49 degrees. I know that this Stadia mark is 0.286 degrees below the horizontal line, and in a few moments I'll explain where I got this angle. Next, I was able to take this angular size ruler, I scaled it to the Stadia mark, and then I was able to make an accurate measurement from the horizontal line down to the top of Snaefell, the turbines, the tower, and also the distant horizon. I also did angular size calculations for the size of the turbines and Blackpool Tower, and then that gave me a good idea of where the shoreline on this side would be. So this is an accurate estimation of what Ranty would see when he is at an elevation of 1,475 feet. So this is what Ranty would see if his auto level does have a 1.5 degree field of view. Now Ranty sent me this link about the auto level that he purchased. So the field of view is 1 degree 30 minutes, which is 1.5 degrees. The Stadia has a multiplication factor of 100, which equals 0.286 degrees. Now this is from Bev's channel when he was arguing with Ruhip that Stadia marks are not represented by an angle. Now Stadia marks are used to make estimations of distance, and they are based on this triangle which has a ratio of 1 to 100. And as it says at the bottom right down here, this ratio or this constant k entirely depends on the magnitude of the angle, and they're talking about this angle right here. So when I divide that triangle into two equal right triangles, that gives me a ratio of 0.5 to 100, and that means that each of these angles is 0.286 degrees. So again, those Stadia marks represent an angle of 0.286 degrees both above and below that horizontal line. Now, if Ranty has an auto level that has a smaller field of view, let's say 1.2 degrees, this is what he would see. But the distance of Snaefell, the turbines, and the tower below that horizontal line would be exactly the same. So here are the distances to Snaefell, the turbines, and Blackpool Tower for the 1,000-foot elevation. Also in this case, the standard refraction horizon is closer at 41.8 miles. So again, I started with the flat Earth model, and then I added curvature drop based on the standard refraction curvature rate. Blackpool Tower is 0.15 miles below the horizontal line, which is 0.35 degrees. The turbines are 0.29 degrees below the horizontal line, or 0.39 degrees. And Snaefell is 0.68 miles below the horizontal line, which is 0.43 degrees. Again, I use an angular size ruler scaled to that Stadia mark, and we can see that everything is much closer to this Stadia mark. Also, quite a bit less water is visible. This is what Ranty would see if his auto level has a field of view of 1.5 degrees. And if his field of view is 1.2 degrees, this is what he would see. Now, I don't know what elevation Ranty will be at when he makes these observations, but these estimations give us a very good idea of where Snaefell, the turbines, and the towers will be in relationship to the bottom Stadia mark and his horizontal line. And this is what Ranty would see if he was at 1,000 feet and the Earth was flat. Snaefell would be above the horizontal line. In fact, it would be above the horizontal line if Ranty was at 1,475 feet. I know for a fact he is not going to see this.